more at least.
Like every room I walk into, there's Damien doing science experiments with a camera. Yeah.
Oh, hold on a second.
Spoilers. Press.
Don't
Can
look.
you press 0 on the keyboard to go to the beginning?
Is that how you do it? That didn't work.
It works on YouTube videos.
Okay. Don't look. Everybody close your eyes. It's a secret.
Spoilers.
Okay.
Dr. Damien, the science guy.
Science rules.
What's up, guys? It's Damien, and today we're going to be showing an exothermic reaction, which is a reaction that releases heat, and then an endothermic reaction, which is a reaction that takes in heat. And so right now our thermometers are at 20, and then we're going to show the picture. And so we're going to... What are we going to do again? We're going to pour the hydrogen peroxide in with our yeast, and that should release heat, aka an exothermic reaction. Alright, so our current temperature is 20. Should I put it in this input? Alright. So, this reaction should release heat. Should I stir? Oh, wait, I have to stir it, right?
Yeah. Put more in though. Probably.
Yeah, okay.
There you go.
Alright. Our temperature is 23 and rising. "24 and rising." And it has seemed to stabilize at 24. And that should be it about done. Yep. It's not going any higher. And now for our next experiment, right?
I'll take your equipment. I'm your assistant here.
Yep. Which will be the classic baking soda. And vinegar. And this is going to be endothermic, which means instead of producing heat from a reaction, it'll take in heat from a reaction. Meaning the temperature will go down. The current temperature is 20. It's going to go down from that once the reaction starts. Should I pour more? Oh yeah. Yeah. Alright, the temperature is 17. 15 and lowering. Still 15 and lowering. I think it's going to go to about 15 and a half. Oh, no. 14. And it stays at 14. Can you zoom in on it right here? So when we mixed in yeast with hydrogen peroxide, we got an exothermic reaction. And when we mixed baking soda and vinegar, we got an endothermic reaction. We are doing the what effect does molarity have on reactions? We've got acid with molarity strength 1, acid with molarity strength 3, and acid with molarity strength 6, with molarity strength 6. And then we've got zinc Each of them is roughly 0.3 grams. We round it up for scientific purposes. And now we're gonna time how long each reaction is.
Here we go.
3, 2, 1. That's kind of underwhelming. So my hypothesis is the strongest acid with the highest molarity is gonna be the one that reacts the fastest. Because molarity is just the amount of particles in a volume. So this has a lot of particles of acid in its volume. Okay, 3, 2, 1. Already, I'm seeing way more bubbles. Compared to that one anyway. Ooh. 3, 2, 1.
Whoa. Look at her go. It's going crazy.
What time is it, man?
Science rules.
Alright, I'm Damien, and today we're doing an experiment with water and Alka-Seltzer. This experiment will be testing the effect that temperature has on a reaction. My hypothesis is that the hot water at 75 degrees is going to react the fastest, and the cold water at 12 degrees is going to be the slowest. So we got our initial temperatures here, and then we're gonna try to calculate how long it takes for them to reach their final temp after having the Alka-Seltzer put in. Start the timer now. The reaction was instant. It was instant. It was instantaneous. Okay.
Stopping. Wait, we have to record that time first.
It was like a second.
No, it's already over, so 13.65 seconds.
13.65 seconds.
Write that in the first box there.
Alright. And I don't think the temperature changed.
It might. We can look at it after. Or you can look at it now if you want.
Alright. For the hot water, it was 72.
Alright. What kind of reaction is it then?
Well, I mean, you gotta factor in that the temperature was already going down for the
Alka-Seltzer.
too, but
True.
I guess it was an endothermic.
Alright. Let's do the next one.
Alright, the next one, room temperature at 22 degrees. Putting in the Alka-Seltzer now. It's taking a while. The cold water, which is at 12 degrees. 3, 2, 1, start. It's officially been longer than this one, right?
Officially, yeah.
Yeah, okay, so my hypothesis was correct. Although it was a very broad hypothesis. My hypothesis is that the hot water at 75 degrees is going to react the fastest, and the cold water at 12 degrees is going to be the slowest. Is it over? Alright. And the final temp was? And the time was?
1 minute and 35 seconds.
And let's Second.
Those are seconds. The other ones are seconds.
No, no seconds.
0.14.
Min, sec, mil.
Okay. Do you want to make a conclusion?
Yep, in conclusion, the hotter one had a faster reaction than the colder ones.
Why is that, scientist Damien? What's happening?
The hotter temperature is accelerating the reaction.
Why? What's happening to the molecules?
The molecules are moving faster.
There you go. And
Dr. Damien, the science guy.
Science rules.